Welcome back to TechPub's Mastering ASP.NET MVC2 series. In the last controllers episode, you saw how controllers are implemented as .NET classes. You saw how to receive input using request context objects and parameter binding, and how to produce output using action results. In this episode, we'll push much deeper, learning ways to control how your application interacts with HTTP, such as how it maps requests onto .NET methods, and how to use the full range of HTTP verbs like post, get, and delete. We'll also look at how you can set up a custom controller factory, and then use the dependency injection pattern to keep your architecture cleanly decoupled. And finally, we'll think about ways to scale up to handle high volumes of traffic using asynchronous controllers. Okay, let's get started in Visual Studio, and we'll consider how we can control which C# method handles a request, and also look at some ways of dealing with different types of HTTP requests. So firstly, I've got this extremely simple controller with a single action method on it that just returns a view. And the view, if we switch to that, just displays a simple form, and the form just has one text box on it and a submit button. So if I run this in a browser now, you see it asks me for some text, and if I type in some text, submit the form, well, the form just goes blank. And that is because, if we look at the HTML source, because I didn't specify where the form should post, so by default it posts to the same action, and we know that that action just simply renders a blank form. So instead of just losing whatever data the user enters, we want to add a new action that's going to be able to process the incoming data and do something with it. And we know that the form tries to post to an action called myAction, so I'll need to create a new C# method called myAction, and I will say that it's going to receive some text from the form, and it will return, let's say, just some text to say what the user entered. And let's try to be in the good habit of HTML encoding any user supplied text. Right, I'll just run that now. We've got a problem. In the URL we can see that we've only specified the action name of myAction, and so as far as the MVC framework is concerned, this is ambiguous. There are two methods that this could refer to. So we have to give it a way of choosing one rather than another. We want to say that this first method will only be used when it's a GET request, because that's what the user will use to request the form originally, and the second method should be used when it's a POST request, in other words when the form has been posted back. I can do that using a method selection attribute, such as the following. And now this second method will take priority if it's a POST request, and if it's not a POST request, the framework will fall back on using the lower prioritized method above. And just so you know, in ASP.NET MVC version 2 there's a shorthand way of doing that. I can just write HTTP POST. So let's try that now. Firstly, if I do a GET request to myAction, it brings up the form, and if I do a POST request to it by submitting the form, it runs the other action method. Now you know that HTTP methods aren't limited to GET and POST. There are a number of others, such as put and delete, and I might want to involve these in my application. So let's say I want to be able to deal with a put request as well. So I might copy that method there and say that we're going to have another action method that responds to put requests, and I'll just make sure we can tell when that one's been run. So that's marvelous, and if I try to compile that, I initially get a compiler error, and that's because we've got two different methods now that have got exactly the same signature, and the C# compiler isn't going to be happy with that. So I'm going to have to make the C# compiler happy now, and that's great, except that the MVC framework now doesn't know to associate this method with an action called myAction. So I can use the action name attribute to say that this C# method should be associated with the action name myAction, regardless of what its actual method name is. And now I can run this again, and now a GET request will bring up the form, a POST request will bring up the POST action, but what if I want to do a PUT action as well? Well, a browser is not normally very good at doing requests of types other than GET and POST. So ASP.NET MVC has the concept of HTTP method overriding, and in my view I can say that this form should be treated as being submitted using a PUT request, like that. And now if I resubmit this, we'll see that we've actually fired the put method. And to see how that works, let's have a look at the HTML source code there, and you can see that we've now rendered a hidden field called XHTTP method override, and that specifies how the MVC framework should treat the request. You can also specify a method override parameter as a query string parameter or as an HTTP header, but it's quite convenient to do it as a hidden field. So that's how we've been able to control how a single action name, myAction, can map to any one of 3 different C# methods, depending on whether it's a get, put or post request, and also independently of the actual C# method names that we're using. You've now seen some specific examples of action method selection, but we did go very fast and you might not have a completely clear picture of what's going on. So let's step back and understand the algorithm that aspmvc uses when choosing which .NET method to invoke. When the routing system hands over control to your controller, it supplies an action name, which is just a string. The controller needs to find a .NET method to invoke. So first, it uses reflection to find all its own public methods, but when it builds the list, it doesn't necessarily use the .NET method name, because if you've got an action name attribute, it will register that method using whatever arbitrary string you nominate. The names don't need to be unique. So now it's got a set of candidate methods that correspond to the incoming action name. Next, it eliminates any candidates that have a mismatching action method selector attribute. HTTP GET and HTTP POST are both examples of action method selectors. So if it's a GET request, it will eliminate any method with the HTTP POST attribute. Now, it gives special priority to methods that have one or more method selector attributes. If there's exactly one of those, the algorithm terminates and it uses that one. But if there are multiple high priority candidates, this is an ambiguous match and it terminates with an exception. And if there weren't any high priority candidates, it will fall back on using candidates that don't have method selector attributes. Again, if you've got exactly one, it will use that, and if you have more than one, it's an ambiguous match. You might wonder why there's a distinction between high priority candidates and other candidates. It's easy to understand with an example. If you have 2 methods, one of which has an HTTP POST attribute and the other one has no attributes, then if it's a POST request, both methods will be treated as candidates because neither gets filtered out, but only the POST method is high priority, so that will be used. On a GET request, only the GET method would be a candidate because the HTTP POST attribute would filter the other one out, so the GET method would be used. Finally, if there were no candidates at all, because the action name doesn't correspond to any method, then the controller will invoke a special method called handleUnknownAction, which by default raises a 404 not found response. You can override this method if you want and provide custom behavior. I've never seen anyone actually want to do that, but it's nice to know that you could. Now so far, the only action method selector attributes you've seen have been HTTP GET, HTTP POST and HTTP PUT, but it's an extensible framework, so let's now see how you could create your own custom action method selector attribute. As an example, I'm going to create a custom method selector that catches requests made by iPhones. First, let's use this iPhone simulator to see that when we request the myAction action normally, it works just the same as it would on a PC. Next, I'll create a custom action method selector class by inheriting from the action method selector attribute base class. All I have to do is override the isValidForRequest method. Just tidy that up slightly. And the logic I'll use in this case is just to check the incoming user agent header and see whether it looks like an iPhone. If it is, then we'll allow the method to handle this request, and if it isn't, we won't. Now back on my controller, I can create a new version of the action and use the new iPhone browser selector on it. I'll just change the behavior. I could redirect the user to an iPhone specific page, but in this case I'll just display a message. Notice that I've got another method name clash because I've got 2 methods both called myAction that take no parameters, so I will change the name of this method slightly, and of course tell ASP.NET MVC to map it back to the same action name. And now if I compile this and check it out in a browser, I should see that the behavior on a normal browser hasn't changed. But in my iPhone simulator, if I reload the page, you can see that the iPhone specific action has kicked in. And the point to notice is that both devices are requesting the same URL, but my custom action method selector lets me use arbitrary logic to map the request to different C# methods. Let's move on and think about how controllers get instantiated in the first place. Normally, the MVC framework gets a controller parameter from the incoming URL, and it uses this to find a matching class in your assemblies and then calls that class's parameterless constructor to construct one. But what if you want to pass constructor parameters to your controllers? Or what if you want to use some other custom logic to instantiate them? In that case, you can make your own controller factory class. The most common reason why people do this is to support the dependency injection pattern, which is also called inversion of control. You may have learned about this pattern from the TechPub inversion of control episode, but just in case you haven't, I'll try to summarise it in 1 minute. Let's start with a visual demonstration. If you have a custom controller factory, then when the MVC framework begins processing a request and needs a particular controller type, it will ask your controller factory to supply an instance. Your controller factory will probably scan your assemblies for the requested type. But when it's found that type, it might find that it has some dependencies of some abstract interface types. If so, your controller factory will need to decide which concrete types to use for each abstract dependency. The controller type might have multiple abstract dependencies, and so your factory will decide which concrete type to use for each one. Finally, you'll have got all the dependencies in place, so then you can return a fully instantiated and populated controller back to the MVC framework. The benefit of all this is that the controller then doesn't even need to be aware of any particular concrete types that it depends on. Instead, it can just depend on abstractions like interfaces. This is the basis of a loosely coupled architecture, where you can easily swap out any component for a different implementation that satisfies the same interface. Another benefit is that it makes unit testing possible, because unit tests can then supply fake dependencies instead of the real ones, for example a fake data access component that simulates a particular set of test data. I know this all sounds very complicated, and it would be, except that in the .NET ecosystem there are loads of really good open source inversion of control tools that take the pain away. Let's now see how you can do all of this in just a few lines of code using a popular tool called ninject. We're going to be extending the job ads application from the previous controllers episode. First, if you remember, there's a jobs controller which has a search action. So, in their browsers, people can bring up the search form and then they can have a look to see what's available. That all works very well, except if you look at our code, you can see that we're tightly coupling this particular controller class to this particular dependency. There's no way to substitute in an alternative job ad repository. So what we might want is to make this into a constructor parameter instead of having a hard-coded dependency there. I'll create this constructor which takes a job ad repository parameter. And now I can eliminate the hard-coded dependency. That's great, but what happens if I try to run this in a browser now? You can see we get an error because aspmvc has no idea what parameters to pass to the controller. Let's fix this using ninject in a custom controller factory. First, we start by downloading ninject from its website, ninject.org, but I've already done that, so I'm just going to add a reference now from my MVC project. I only need to reference ninject.core, I won't need any of ninject's other assemblies. And now I'll create a new class to act as my custom controller factory. The easiest way to make a custom controller factory is to inherit from default controller factory. If you do that, then you only have to override one method, getControllerInstance, and it tells you exactly what type of controller it wants. You just have to return one. Now I'm going to do this using ninject, so first I have to create a custom module for ninject that it uses to configure itself. Inside my module's load method, I can use ninject's bind method to tell it how to map abstract types onto concrete ones. So I'm saying here that whenever it requires an iJobAd repository, it should use the concrete type dbJobAds repository. Now I've set up a configuration module, I can create an instance of the ninject kernel which will be able to return types. I'll tell it to use my configuration module, and now my getControllerInstance method can ask ninject to supply controller instances. Better cast that to iController. One thing to bear in mind is that sometimes the MVC framework passes null as the controller type parameter if it doesn't know how the incoming controller name maps to a type. In that case we'll just return null. So that all compiles and works, but now I need to tell ASP.NET MVC to use the new controller factory that I've just created. I'll go over to my global.asax.cs file, and inside this method, which runs when the framework first starts my application, I'll tell it to use my custom controller factory. Right, I'll compile that and give it a go. If I reload this page, we found that it now works. So ninject has seen the constructor parameter that our controller requires, looked at its own configuration, and supplied a concrete instance of the correct type. And jobs controller no longer needs to know about any particular concrete dependencies. That was easy, and it's going to come in very useful in a few minutes when we add an extra dependency to jobs controller. Our final topic in this episode is asynchronous controllers. This is a new feature in ASP.NET MVC 2 that, under some circumstances, lets your controllers handle requests more efficiently so your server can cope with significantly more traffic. This episode's been a bit intense so far, so let's sit back for a moment and understand the problem that asynchronous controllers deal with and the way they solve it by analogy to a situation you might experience in your office. We have a manager who asks one of his employees called Bob to carry out a task. Bob agrees to do the task. He knows that he has to contact a third party to satisfy the request, so he sends an email and starts waiting for a reply. A few moments later, the manager asks Bob to do something else. But this time, Bob refuses. He's already doing something. The manager wants to know what's so important that Bob would refuse to take a sales call. So Bob explains he's waiting for an email. Maybe you'd expect Bob to be able to do something else while he's waiting, but no, Bob explains that waiting for an email counts as being totally busy. Of course, the manager isn't very pleased about this. Now, this is analogous to the way that the core ASP.NET platform handles requests. There's a finite number of worker threads in the worker thread pool, and when one starts handling a request, it stays busy until the whole request is finished. If that request involves some long-running input or output operation, such as calling an external web service or waiting for a complex SQL query to run, then the worker thread has to just sit there waiting until it's done. If you have a lot of traffic, then it's possible that all the worker threads might be busy and unwilling to process incoming requests because they're all waiting for external I/O operations. And that's troublesome because you know they're not really doing anything, and yet they can't take on any new work. Now, back in the office, if these workers ran their tasks asynchronously, then when Bob had sent the original email, he could have just forgot about it and got on with some other task. Later, when an email reply came back, it could have gone to any of the workers, not necessarily to Bob, who might genuinely have been busy this time. Whoever received the email reply could then finish off handling the original task. And this is exactly how asynchronous controllers work. Once your controller's started some long-running external input or output operations, you let the action method finish without waiting for those I/O operations to complete. The worker thread gets released and can handle other requests as needed. And then later, when those I/O operations complete, ASP.NET takes any available worker thread from the pool, reattaches it to the original request context so that it knows what it was doing, and lets it complete the request. And so none of the worker threads have to be blocked while waiting for I/O, and the whole thread pool can be used to its maximum capacity. Alright, that's enough talk. It's time for some code. Let's add an asynchronous operation to jobs controller. One limitation of our application at the moment is that it doesn't deal very well with spelling mistakes. If someone misspells a query, it will just return 0 results. We might want to be a bit more helpful than that. Let's add a spelling corrector using an API provided by Google. Back in my application's domain model, I've got an abstract definition of a search suggester service. We only need to think about this method at the moment because we're just trying to implement this functionality synchronously. If we supply some text, it will supply some spelling corrections. I want to make the jobs controller dependent on this service, so I'm going to add an extra constructor parameter, and I'll assign that to a local field. If I try to run the application now, I'll get an error, because an inject doesn't know which search suggester we want it to use. I'll go to my controller factory configuration and tell it. When somebody asks for a search suggester, we'll use a concrete type called Google Search Suggester. Don't have to worry in detail about how that works, but it just happens to use a Google API to provide the spelling suggestions. So in my controller, I can see if there are any corrections for the incoming query. I want to pass that information on to be rendered in the view, so I'll add a new field to my view model and assign the value that came back from the service. Finally, I'll display this in the view by adding a bit of extra view code. I'll just say if there was a spelling suggestion, then I'll render it in a new span. Did you mean? And I'll use the action link helper to render the suggestion as a link that would take you to the results of the suggested query. So that's a link to the search action, and the parameter we want to pass there is that the query would be the search suggestion. So now I'll rerun my query with the bad spelling, and you can see we do get a good spelling suggestion, and if I click that, I'll get some results. Marvellous. But when we ask Google for these spelling suggestions, we don't know how long it's going to take to reply. It might take several seconds, and our worker thread will just be waiting doing nothing during that period. So ideally, we perform that request asynchronously so that the worker thread can do something useful while it's waiting. Back on the iSearch Suggester interface, you'll see these two other methods that help us to run the operation asynchronously. The begin method takes the source text, and instead of returning the suggestions, it returns an iasync result, and that acts like your receipt, so that later on you can pass your receipt to the end method and it will give you the final result from your inquiry. You can also specify a callback parameter that it will call to notify you when the results are available. If I want to use this in Jobs Controller, I have to go through a 4-step process. First, instead of inheriting from Controller, I need to inherit from the standard async controller base class. Now I've done that, requests to this controller will be processed using an asynchronous pipeline, which has fractionally more overhead, but it does allow the framework to release the worker thread in the middle of the request. Next, I need to split the search action into two parts. One part that will run in the first half of the request, before the operation completes, and the second part that will run after the operation completes. Because the action name is search, the first half of the implementation has to be called search async, and it returns void because it doesn't return the final result to the user at this stage. First, we'll forget about the spelling suggestions and just try to get the database query working. So we'll move up the code that does the database query into the async method, and we'll put the results into a dictionary called asyncmanager.parameters. Now we can implement the second half of our action, which has to be called search completed. Instead of taking its parameters from the request context, it takes its parameters from the asyncmanager.parameters dictionary, so we can get the search results view model that we created earlier. Now let's just adapt the existing code so that it works with the view model parameter. And now this slightly odd looking code should work perfectly well, although we will have lost the spelling suggestions feature. I'll try that. Okay, so no spelling suggestions, but it does otherwise work. Now let's try and add this asynchronous call to the Google API. First, we have to tell aspmvc that we're waiting for an asynchronous operation to complete. Then let's actually begin the operation. We'll pass along the query, and we can also supply a callback that it will invoke when the final data is ready. We can express this callback as a lambda method. Inside the callback, we know the operation's finished, so we can ask it for the final result. We just call the endGetSuggestion method, passing along the async result, which is the receipt that we got when we started the operation. We need to make this data available in the completed method, so let's put it into the async manager's parameter dictionary. And finally, we better tell aspmvc that our asynchronous operation is finished, otherwise it will never call the completed method. Of course, you can run as many asynchronous operations in parallel as you want. The framework will count how many are outstanding and call your completed method when the count reaches 0. So let's update the completed method to receive the search suggestion. And we can simply assign that to the view model. And now if I run the code, the suggestion feature should have come back. Which is great for people who can't spell. As you can see, running the operation asynchronously does make the code a lot more complicated, but it does have the benefit that the worker thread doesn't have to wait for Google to reply, and now we don't really have to worry how long it takes Google to reply because it won't add any extra pressure onto our thread pool. We also get a secondary benefit, which is that the call to Google and the call to our database are now running in parallel instead of in sequence, so any individual request might complete fractionally faster. Having seen all this, when is it actually worth using asynchronous controllers? First, it's important to point out that they're only intended to help when you'd otherwise have worker threads waiting for external I/O. They're not intended to help if you just have a set of CPU-bound operations that you want to parallelize. If that's the case, you should just use .NET 4's parallel.invoke or the older threadpool.queueUserWorkItem API. Asynchronous controllers only relieve pressure on the thread pool if you're waiting for a callback from an I/O operation that can signal completion without blocking a thread in the meantime. For example, The web request class and the SQL client classes both have proper asynchronous APIs that can give you callbacks without blocking worker threads. Second, it only makes a difference if you wouldn't otherwise have enough worker threads to handle the traffic. By default, ASP.NET allows for up to 100 worker threads per CPU in your server, and of course you can change that configuration. Now if each visitor makes a request every 5 seconds, and each request takes an average of half a second to complete, that means you'd need at least 1,000 concurrent visitors per CPU to keep all 100 worker threads busy. Most sites don't have this issue. Third, don't try to use asynchronous controllers everywhere on your site. They make the code much harder to understand and maintain. Try to be strategic, perform load testing, and only use it on the few actions where it will actually make a difference. You probably don't want to make your SQL data access asynchronous, except perhaps one or two especially lengthy queries. The whole idea of asynchronous requests doesn't fit well with a lot of ORM technologies, especially link-based ones where it contradicts the elegance of deferred execution. If the queries have to run asynchronously, then you have to be very explicit about when the query runs, and not just leave it to deferred execution or lazy loading. In summary then, asynchronous operations can be a powerful performance aid, letting you break free of worker thread pool limitations without slowing the whole system down by having too many worker threads. But you need to be strategic and selective about where you use them. Well, I hope you've enjoyed this episode of TechPub. See you again soon.